mean score on the Math MCAS grade 10 level was 515 in 2000. An educational researcher claims that students who study algebra in the 5th grade have higher scores. He obtains a random sample of 40 students from schools who have students do algebra in the 5th grade and finds that their mean score is 540 with a standard deviation of 90. He wishes to test the claim at the alpha equals 0.05 level. So, what kind of test is this? Mean. What are the null and alternative hypotheses? Let's see. His claim was students who study in algebra have higher scores. So it's definitely going to be a greater than, and it's going to be higher than the mean of 515 in 2000. So we have the mean equals 515 and the mean greater than 515 because he thinks studying algebra in 5th grade helps. And his alpha was 0.05. So our sample mean was, we had 40 students. So that's our sample size. Our mean score was 540 for these students, and their standard deviation was 90. So we'll go down to the next step. Step 5, we do a t-stat or a proportion stat. So we're going to do a t-stat, one sample with summary, and copy in the data from this question. 540, 90, and 40. Our hypothesis test was that we're equal to 515 or we are greater than 515. And when we compute, we get a test statistic of t equals 1.76 and a p-value of 0.0434. So our test statistic we write in t equals 1.76 and p is 0.0434. We are less than alpha in this case, because our alpha was 0.05, so we're going to reject the null hypothesis. So we'll go to the top. If you reject the null hypothesis, there is sufficient evidence to support the claim, and go back to what the claim is. The claim is that algebra in the 5th grade leads to higher MCAS scores. Notice we don't say that it's as high as our sample because that's just one sample. We just know that it's higher at the alpha equals 0.05 level. Any questions? All right. 2 more examples. Example 5. According to a 2010 survey, the mean number of apps downloaded by iPhone users is 40. Suppose a sample of 36 iPhone users downloaded an average of 45 apps, and the sample standard deviation was 24. Test whether the population mean number of apps has changed using alpha equals 0.10. So we have a mean test. The 2010 survey said the mean was 40, so that's going to be our null hypothesis. And our alternative hypothesis asks whether the population mean has changed. So we're looking at the mean not being 40, and we have a two-tailed test. Our alpha equals 0.10. Our sample mean was, we had a sample of 36, so sample size 36, an average or mean of 45 apps with a standard deviation of 24. Right, so I'm going to go down to the bottom. So we're going to use t-stat, or we're going to use proportion stat, and that tells us t-stat. All right. So our t-stat, oops, t-stat, one sample with summary. Our sample mean was 45. Our sample standard deviation was 24, and our sample size was 36. Our hypothesis test was looking at 40, and we want to leave it as a two-sided test with the not equal to sign here. And when we compute, everything looks the same. We have a t-stat here of 1.25. That's our test statistic. And a p-value of 0.2196. So we go back to our test. Our test statistic we had t equals 1.25 with a p-value of 0.1098. So if our p-value is greater than alpha, we do not reject the null hypothesis. So since we can't reject, there is not sufficient evidence to make a conclusion that the number of apps has changed. Okay, since we're doing it using StatCrunch, it kind of takes care of the dividing by two thing that we have to worry about if we're not using StatCrunch. So it kind of takes care of it for it. All right. And we have one test left. Okay, number 6. The National Institute on Alcohol Abuse and Alcoholism reported that 46.5% of 8th graders had used alcohol. A random sample of 100 8th graders showed that 41 of them had used alcohol. Is there evidence that the population proportion has changed? Tested at the alpha equals 0.01 level. So here we have a proportion test. So we're talking about P. The original number is 46.5%, so 0.465. And they're just asking if it's changed, so we do a not equal to 0.465. And they're looking at alpha equals 0.01 level. Our proportion had a sample of 100 students, with 41 of them having used alcohol. So that gives us our first page, or the top of the chart, I guess I should say. And down to step 5, we need to use proportion stats. Okay, so we're going to do proportion stats, one sample with summary, and fill in our data. Our number of successes was 41. Our number of observations was 100. We're doing a p-test with p equals 0.465 and a not equal to 0.465, and we compute. So we have a test statistic of z equals negative 1.0 and a p-value of 0.2702. Going back to our assignment, our test statistic was our test statistic is z equals negative 1.10 with a p-value of 0.2702. So our p-value is greater than alpha, and we cannot reject the null hypothesis. There is not sufficient evidence to make a conclusion that the proportion of 8th graders who have used alcohol has changed. Okay, any questions?